Hello guys, welcome to another video from Comtower channel. In this video, actually we're gonna start a new playlist, and in this playlist we're gonna solve every question from CLRS textbook. And as you know, CLRS is one of the most famous book in algorithm, data structure, and some other issue like cryptography and other things. And if you are a student in computer science, you must read this book. This is one of the most important, and actually it's like a basic for you guys. And in this part, we're gonna solve the every question and exercises in section 1.1. And yes, that's it. Let's solve it together. Okay, guys, as you can see, I write every problem first and then I write a solution for them. The first problem is that give a real-world example that requires sorting, or real-world example that requires computing in a convex hull. For sorting, we know that in some websites like Amazon, we need to sort product by price, rating, or other things so user can easily find what they want. Sorting enable efficient searching, display, and comparison operation. Actually, we use some algorithm for sorting, and we will read this sorting later, but just for calling them, we use from merge sort or quick sort. And after that, actually, we will prove this issue that if you use every sort based on comparing, your efficiency will be in order of n log n. And yes, that was for sorting. And for convex hull, let me first tell you what is a convex hull. Assume that you have n point in the plane, and we wish to find the convex hull of these points. The convex hull is the smallest convex polygon containing every point. Actually, this is the definition of convex hull, and we use this actually definition in computer graphic and robotic. Convex hull are used for object boundary detection and collision avoidance. And yes, we will use this issue in these topics. And yes, that was the first problem. The second problem is that other than speed, what are measure of efficiency might one use in a real-world setting? Besides the speed that we call it time complexity, we also consider space efficiency. For example, in embedded system, memory is more limited than CPU time. We have power consumption, scalability, reliability, and fault tolerance, and other things like these. And yes, that was the answer for question number 2. For question number 3, select the data structure that you have seen previously and discuss its strength and limitation. Actually here I use from hash table. We know that in hash table, average case time for search, insert, and delete operation is O1. And actually this is really good for symbol table, databases, and caching. Or better I say a little example is that assume that you have a set and you want to find out there is one actually a specific element in this element or in this set or not. We will use from hash table, and if we use it, we can find it in O1. And after that, it says that performance degrades to ON in worst case if hash collision are frequent. And we will read about this issue later. Requires good hash function to avoid clustering, doesn't maintain order of key. And yes, that was the answer for question number 3. For question number 4, how are the shortest path and traveling salesman problems similar? How are they different? Similarity of this problem is that both involve finding optimal paths in a weighted graph. Both use graph theory and can involve similar data, nodes, and edge. And actually the difference is that in the shortest path problem, the path is usually unique. The path is usually unique, and it is not required to return the starting point, and the end point is a specific destination. However, in the traveling salesman problem, the starting and the ending point must be the same, and all nodes must be visited. And now the final problem, come up with a real world problem in which only the best solution will do, then come up with one in which a solution that is approximately the best is good enough. best solution record we can use from cryptography or password hashing. Security algorithm must be exact. Even a slight deviation or approximation can lead to, actually I don't know, a mistake in our system. For example, you can use from RSA key generation, and this is one good example. And for approximate solution acceptable, you have route optimization for delivered trucks. Actually, this problem is like a traveler salesman. We will read it later. That is one of the MP complete problem that you will read it about it. Actually, this type of problem, you don't have a specific algorithm for finding the best answer for this type of question, but you can assume some hypotheses for this question, and after that find the algorithm for them. And yes, this is the answer for every question in section part 1.1. I hope you guys enjoyed this video. Actually, this part was like a intro to the solving every question in CLRS textbook. If you like this video and subscribe to my channel. And if you have any idea, opinion about my video, you can leave it in comments part. And that's it, guys. Have a nice day, guys. Goodbye.